Hey Van friends, things are about to get really nerdy around here. Let's talk about Victron Energy's DVCC, which stands for Distributed Voltage and Current Control. DVCC is a sophisticated way to control charging your batteries in a coordinated way where all of the compatible chargers work together and are aware of what each other are doing in terms of charging and voltage and optionally temperature. Also, in our testing, it appears to control priority so that, for example, your solar array can be the first priority for charging, maximizing its capability, while the other chargers, like a multi-plus inverter charger, produce less to maximize the free power over metered power. DVCC is unlocked by having a GX device in your system, such as one of the many Cerbo devices or an Ekrano, which serves as the computer or the brains of the operation. Once you have the GX device, pretty much any Victron charger with a data connection can work with DVCC. That's anything with a VE Direct, VE Bus, or VE CAN port, including products like the newer Orion XS 50 amp DC to DC charger, solar charge controllers, inverter chargers, and so on. Be sure you're using the latest firmware on your chargers. There are also a few non-Victron devices that will work, and we'll touch on those later. DVCC works best when paired with smart lithium batteries that have CAN bus enabled BMSs. In those environments, it allows the batteries to take charge of charging, pun intended, and control the charging parameters instead of relying on old-fashioned charge profiles. CAN bus communication to the batteries is a killer feature, but it's somewhat rare. We expect more batteries to add this capability in the not too distant future. For now, Victron Smart batteries paired up with the external BMS, called the Lynx Smart BMS, is a very popular option, and with the price drops over the last little while, they're refreshingly affordable. Another notable example are e-Pick batteries that we sell in our store, which have an internal BMS with Victron capable CAN communications. So what do we mean by batteries controlling the charge parameters? Without DVCC, you would configure the charge profile in the settings of all of your chargers after wiring up the system. With Victron gear, this is typically done through Bluetooth with the Victron Connect app or with an MK3 to USB adapter for inverter chargers. So you'd find the specifications from the battery manufacturer and configure things like the absorption voltage, the absorption time, float voltage, etc. and so on. Then, with all the chargers configured, they would each monitor the voltage of the battery bank to determine which stage of the charging cycle they should be in, moving from bulk to absorption and then into float, but without any consideration of each other. This can create a number of, let's say, less than ideal situations. For example, a more powerful charger could increase the battery voltage, causing the other chargers in the system to stop charging, falsely assuming that the battery bank is fully charged. Also, since the chargers are basically only monitoring voltage instead of actually communicating with the battery or the BMS, anytime the battery drops below the absorption voltage, a new charging cycle can get started. So, every time you start the engine, in the case of a DC to DC charger, or every time you plug into shore power in the case of an inverter charger, a new charging cycle would start. This isn't a big deal, but it does create unnecessary burden on the battery lifespan. And then there's the simplicity of just wiring up your system and not having to muck around with any of the charge profile configuration at all. Particularly with an all Victron system with the Lynx Smart BMS, as soon as you connect up all the data cables in the system, DVCC is forced on and it takes care of all of the configuration. All you have to do is set the voltage of the system, the size of the battery bank in amp hours, and the number of batteries that you have, and everything is set up and you're on your way. Now, technically, you should set a charge profile in the different chargers in case the digital communication that DVCC relies on fails, but in our experience, this is very rare. Configured in this way, you'll notice that the chargers in the system indicate that they are under external control on the Cerbo GX touchscreen or inside Victron Connect. This means that the batteries are in charge of the charging. Another cool DVCC feature is the ability to set a system-wide maximum charge current or maximum charge voltage. So let's dive into that a bit. When considering lithium batteries, most people are aware of the storage capacity in amp hours. How much power can the battery store and provide to the system? But you'll also need to know about the energy throughput of your system. What is the recommended charge and discharge current? Those detail how quickly you can recharge, or how much energy you can put into the battery, max charge current, and how much energy you can simultaneously use when powering your loads, like air conditioners, fans, lights, etc. That's the max discharge current. And just like the storage capacity, when you put more than one battery into a bank, wired in parallel, these throughput capabilities are added together. As an example, this ePIC 460 amp hour battery has a recommended continuous charge current of 100 amps and a recommended continuous discharge current of 100 amps. Or, for short periods of time, maximum charge rate of 230 amps and 300 amps for discharging. If you put two of these in your system, you'd have a fairly massive 920 amp hours of storage capacity, but only 200 amps of throughput on the charge and discharge. In some systems, like those that use a dedicated secondary alternator for super fast, reliable charging, that 200 amps of charging could be exceeded by the alternator alone, since it can produce over 200 amps, and if you had solar or other charging sources, you'd be way over the limit. So you can see how sizing your battery bank for throughput, in addition to storage, is so important when designing a system. In this scenario, you could use the limit charge current feature of DVCC to, well, limit the charge current across the entire system so that all the chargers never exceed 200 amps. For those astute viewers who are familiar with our secondary alternator power systems, you'll know that they're regulated by a Wakespeed WS500, which is not a Victron component, but the latest version of its firmware, starting at 2.5.2, has support for Victron DVCC. More information about that in the configuration guide for the Wakespeed that we'll link below in the description. Alrighty, let's demonstrate DVCC in action. Here we have a test system on this bench that has one ePIC 460 amp hour battery connected to the BMS CAN port on a Cerbo GX. You'll see that there are two RJ45 network style CAN ports on the battery. One has a blue cap for Victron side, and the other has a black cap that connects to the included battery monitor. This system also has an Orion XS 50 amp DC to DC charger, and this other battery, which is acting as a surrogate for a vehicle starter battery that would normally be wired up to the input side of the DC to DC charger. The Orion XS is communicating with the Cerbo GX through its VE direct connection. This is one of the many new awesome features of the XS Orions. We also have a Multiplus 123120 inverter charger that's communicating with the Cerbo GX over VE bus. In this test system, we actually have two battery monitoring shunts. There's one that's built into the ePIC battery, and we also have a Victron Smart Shunt here for testing and comparison. You normally wouldn't do this, we're just nerding out for the sake of our testing. Jumping over to the Touch 50 control screen that's connected to the Cerbo GX, notice that we're using the new, currently in beta, user interface for the GX device. Let's first go into Settings, System Setup, and you can see that we can choose between the two battery monitors to determine which one is reporting to the system and showing on the screen. We've chosen the Smart Shunt as the battery monitor, but we could switch to the one that's built into the ePIC battery. By the way, we just touched on a few of the cool, unique features of these ePIC batteries. That integrated battery monitoring shunt and the Victron compatible CAN communication. Some other cool things in these are mounting brackets, an internal heater, and a high-quality T-class fuse inside the case for safety. These are really cool batteries and available in our store and in our bundled kits. Now let's navigate to Settings, DVCC, and see where the magic happens. You'll notice that we have DVCC enabled, as well as the Limit Charge Current feature, which is set to 100 amps. And that's the battery's happy place, a 100 amp maximum continuous charge current. Meanwhile, this particular system is capable of charging at around 170 amps. The Multi-Plus alone can push 120 amps, and the Orion XS another 50. So we've already benefited from DVCC's ability to intelligently control the various chargers and limit their output. Note that the maximum charge current configured in a device itself using Victron Connect are still in effect with this setting. So in this system, that would be the max charge settings for both the Orion XS and the Multi-Plus. But in your system, it could also be another Victron charger like a solar charge controller. As an example, if we were to throttle down the charging capability of the Multi-Plus from its maximum of 120 amps to something like 50 amps, which is below the DVCC system-wide maximum currently set to 100 amps, the 50 amps configured at the Multi-Plus will be used. One thing you'll notice as we demonstrate the system is that when we set the maximum charging values, the loads on the system are not accounted for unless they are monitored by a dedicated current monitoring shunt. In our tests, there are small DC loads like the Cerbo GX, its touchscreen, that are monitored by the smart shunt in the system, but that smart shunt is not referred to or not configured as a DC meter. What you see on the main system smart shunt is the sum of all incoming current from the chargers minus these little DC loads. If you did want to use, let's say, another smart shunt as a DC meter so that you could account for those kinds of loads in the total max current calculations, you could add a second or third or fourth smart shunt as a DC meter, and we'll link to the manual below that has details on how to accomplish that. That said, DVCC can account for loads when those loads are monitored. For instance, in this system, the Multi-Plus inverter charger can monitor the consumption it's using to operate the loads it's powering, and then compensate for this when it comes to maximum charge current. And we'll demonstrate that a little bit later in the video. Okay, the battery is sitting at 86% state of charge, SOC, so let's start charging. The Orion XS is off, but if I turn it on using Victron Connect with Bluetooth, you'll notice that I have it limited to 45 amps of its maximum of 50 amps of charging capability. As it ramps up, we should see that it's charging at slightly below that 45 amps. Again, the DC loads. And that is being reported as the alternator on the Touch 50 screen in our system using the new Venus OS interface. Now I'm going to change that system-wide maximum current to 80 amps from 100 in the DVCC settings. This will demonstrate how the system will prioritize free power from the DC to DC charger over what is typically metered power from our shore power coming in from the Multi-Plus. So I'll turn on the Multi-Plus inverter charger, which is connected to shore power so it can also provide a charge. It's configured internally for the maximum charge current of 120 amps, which is the factory default. So what we should see is the Multi-Plus gonna kick in and start charging, but only up to around 35 amps in order to stay below the 80 amp system-wide maximum that we've configured in the DVCC settings. Stated another way, the system will take the first roughly 45 amps from the DC to DC charger, which is the max that we configured for that device, and then fill in the gap between that and our system-wide max of 80 amps by asking for 35 amps from the Multi-Plus / shore power. Now, if I cycle the Orion XS off, you'll see that the inverter will actually pick up the entire load up to 80 amps. And then if I turn the Orion on, it will return to just filling in the gaps and so on and so forth. The same kind of prioritization would occur if we had solar power. In other words, the system through DVCC will prioritize solar power over shore power, free power over metered power. Now let's demonstrate how DVCC can account for loads that are monitored by something like a Multi-Plus or a smart shunt that was configured as a DC meter. First, I'll go back into the DVCC settings on the Cerbo and limit it to a max system-wide of 30 amps of charging. Then we'll disconnect the multi-plus from shore power, so the only charger in the system is the Orion XS, which is still configured for a maximum charge of 45 amps. First, we should notice that the charge to the battery is reduced to 30 amps. That's cool. The DVCC settings are overriding the internal Orion maximum charge. Now let's fire up a load. In this case, a heat gun that's plugged into the output of the multi-plus. This will pull around 50 amps, and because this heat gun's load is monitored by the multi-plus, the current that's being allowed to be produced by the Orion XS increases to its max. Notice on the alternator charging output on the screen is going to go up shortly after the heat gun turns on to compensate for the load of the heat gun. That's pretty cool. So what do you need to use DVCC in your electrical system? First, a GX device, such as a Cerbo GX or a Chrono. You also need to make sure that your Victron devices are up to date using a supported firmware, and we'll provide a table of that here on the screen and also a link below. And then ideally and highly recommend that you should be using CAN-enabled BMS batteries, such as Victron Smart batteries, the E-Pick battery that we've demonstrated in this video, Pylon Tech, etc. Victron actually has a list of tested batteries that work with DVCC that we'll also provide a link to in the description below. The next thing you need is compatible chargers from Victron Energy or other tested components like a wake speed alternator regulator. These all need to communicate with the GX device through something like VE Bus, VE Direct, or VE CAN. We hope this overview of DVCC has been helpful. It's a really great feature of Victron electrical systems that we encourage you to take advantage of. Feel free to ask any questions you might have in the comments below, and definitely check out our website for tons of great blog posts and other videos. And of course, consider subscribing and smash that like button.